Hello class, this is Geometry, topic 7-7. We are reviewing 45, 45, 90 and 30, 60, 90 triangles. However, this time we're given a description in words and we need to try to figure out which one they're talking about and how to find the length of that side. Let's go and draw our pictures. Here we're given the length of the diagonal of a square is 8 on the square root of 2. Okay, 8 on the square root of 2. Find the length of one side of the square. Well, a square, all four sides are the same, which means that those are the same, so we're talking about a 45, 45, 90. I'm going to go ahead and redraw it. Be just a little bit nicer. 8 on the square root of 2, x and x. Now, we could use Pythagorean theorem, x squared plus x squared equals 8 on the square root of 2 squared, but specifically we're talking about a 45, 45, 90. So that means that this is x, x, and x on the square root of 2. So 8 on the square root of 2 equals x on the square root of 2. I divide by the square roots of 2, and I get that x equals 8. So that's one side of my square. We're done. Let's take a look at example number 2. Here we've got an equilateral triangle. That means all three sides are the same. And the length of one side is 11. And we want to find the altitude. Well, I'm looking at this, and my altitude, because it is equilateral, it is also an isosceles triangle. I probably misspelled the word isosceles, but because it is an isosceles triangle, my altitude just cut it in half, which means that this is 11 divided by 2, which is 5.5. Now looking at this, I need to figure out, is it a 45, 45, 90? Or is it a 30, 60, 90? Well, this one happens to be a 30, 60, 90 because this is a 60-degree angle. All the angles on a equilateral triangle are 60 degrees. So that one is 60. That means this one is 30. I'm going to redraw this triangle. X, 2x, x on the square root of 3, where this one is 11, and this one is 5.5. So, my altitude would be 5.5 square root of 3. This was a 30, 60, 90 triangle. Let's go ahead and take a look at number 3. Here we're talking about the perimeter of a square. So I've got my square, and my perimeter equals 40. And I want to find the length of my diagonal. Okay, so I'm just going to go ahead and label that as D. Well, if my perimeter is 40, that means my sides are 10. 10, 20, 30, 40. So all of my sides are 10. Well, we've already mentioned a square and the diagonal, that's a 45, 45, 90. So that means that I'm dealing with x, x, and x square root of 2. So if x equals 10, that means that my diagonal is going to be 10 on the square root of 2. All right, let's go ahead and figure out what example number 4 has to offer us. Find BG and UG. Well, I'm looking at my triangle and I need to identify it. Well, because these are the same, this is an isosceles right triangle, which means that these have to be 45 degrees. So, I know that this is x, x, and x on the square root of 2. So if 6 equals x on the square root of 2, I'll have to divide both sides by the square root of 2. So x equals 6 divided by the square root of 2. Because I can't have a radical on the bottom, I multiply by the square root of 2 over the square root of 2. And I get 6 on the square root of 2 divided by 2. And 6 divided by 2 is 3 on the square root of 2. So that's what this side is. And it's also what that side is. So I'm hoping that you've kind of seen a pattern where if they give us the square root of 2 and we need just regular x, we divide by 2 and add the square root of 2. Hopefully you notice that pattern. If not, you'll just have to continue working out all of these steps. Let's move on to example number 5. Alright, for example number 5, we look at our triangle. It's obviously not a 45, 45, 90. Here they told us that is 30, which means that this one is 60. And so this one is x, 2x, and x on the square root of 3. So we know that 6 equals x on the square root of 3. Divide both sides by the square root of 3. We get that x equals 6 divided by the square root of 3. Well, I need to multiply that by the square root of 3 over the square root of 3. I get 6 on the square root of 3 over 3. And 6 divided by 3 is 2 square root of 3. So that's what x is. So this is 2 square root of 3. And now we need to multiply that by 2. So that means that Fy must be 4 on the square root of 3. Because 2 times 2 makes 4. Let's go and take a look at the last example, example number 6. Well, we need to find a bunch of sides on here, and they've only given us a small piece of this. So we need to analyze. What exactly do we have? Well, here we have a 45, 45, 90. So if I break out my 45, 45, 90, that's x, x, and x on the square root of 2. So if this is 8 on the square root of 2, that means this must be 8. Which means this must also be 8. Alright, well let's take a look at this one. Break it out. This is 30, which means that this one is 60. Which means that this is x, this is 2x, and this is x on the square root of 3. Well, if this is 8, then 2 times 8 makes 16, and 8 times the square root of 3 makes 8 on the square root of 3. So that means this one is 16, this is 8 on the square root of 3. Alright, let's see what these are. So SG. And actually, I don't need this line up top. Well, SG equals 16. LU. Well, that equals 8. UG. Well, that equals 8 and the square root of 3. And SU. Well, that one equals 8. Now, the only other thing they could have asked is if they had asked for LG. Well, that would be 8 plus 8 on the square root of 3, and it doesn't simplify. These two numbers are not the same. It's like combining 8 plus 8x. You simply cannot do that. So, if they asked for LG, this would be your answer. Now, this again was just a review over 45, 45, 90 and 30, 60, 90 triangles, but applying them to diagrams and other situations. So, have a good afternoon and good luck on your assignment.